Hey, welcome back. This is video. Let me get my fingers organized. Oh. I don't know which works best. I don't know whether I'm not going to use my hands. Hey, everybody. Welcome back. This is video number 6 in my series on getting ready to have a go at Advent of Code 2025 in Rust. I need to come up with a shorter title for these. Anyway, thank you to everybody who's been watching them. I really appreciate your comments, especially in my last video. This person pointed out an issue with the formula I was using to calculate distance back to the start point. So what they're saying is I should have called absolute on both sides before I added them together. And that it was probably that I just got lucky really with the puzzle input and the test input. So what we're going to do in this video, we're going to fix that code and then we're going to move on to day 2. We'll see how we get on, but I'm imagining that we'll just do part 1 or probably even just part of part 1. Who knows? We'll have a look at it. We'll see how tricky it is. But yeah, let's fix that code before we go any further. Here we go. So what we need to do is, well, we can do two things. We can use this. So that would be okay, or we could really simplify it to this. So let's try that and see how that works. And so that, and then, yeah, I need an absolute in here. I need an absolute on both sides. Okay, let's run that. So package day 1, part 2, and I get 126 back here. Yeah, and that was the right answer. So that works. Thank you so much for taking the time to explain that. Really appreciate it. This is what I need people to point me in the right direction, point out the mistakes I'm making, because there'll be plenty of them. There's plenty to go at. But thank you so much. Really appreciate it. Let's have a look. Well, actually, yeah, let's fix day 1 as well. So let me grab that. And day 1 down here somewhere, a bit further down. Yeah. There we go. I'll commit that and push that up to my GitHub repository. I'll put a link to that in the description below if you want to have a look at the code. And yeah, really have a closer look at the mess I'm creating. Right, let's have a look at day 2. We'll do the setup first. So I'm going to run cargo init --bin day 2, and that will create me a second package. I'm going to create a bin directory within the source directory. So let's do that. This is so I can have my part 1 and my part 2. You can just see how I've got that there in day 1. I've got my part 1 and my part 2 within the bin directory. And then I can call cargo run --package day whatever, and then --bin and the particular file that I want to call for either part 1 or part 2 of the puzzle. So we'll create the bin directory and then we'll move the main file into it. And then lastly, we'll rename it to part 1. All right. And so this is going to be the hello world that you get with every time you create a binary package. So we can get rid of that. And what I'll do for now is I need to streamline this bit. But what I'll do for now is I'll just copy. Yeah, just copy from my main. I copy my main and my run and my tests from part 1 day 1, part 1, and pop them into my day 2, part 1. So that will all be fine. We'll get rid of all of that. And we'll return. Let's have a look at day 2. A quick look at what the oh well, yeah, we ought to have a look at the puzzle, hadn't we, really, before we go any further. Let's have a look at the puzzle. Bathroom security, a very important topic, dear to my heart. You arrive at Easter Bunny headquarters under cover of darkness. Ooh. However, you left in such a rush that you forgot to use the bathroom. Story of my life. Fancy office buildings like this one usually have keypad locks on their bathrooms. Okay, I worked in a lot of fancy offices. Do they have key? Maybe they do. Yeah, no, I can't remember the last fancy office I worked at that had a keypad to use the bathroom. Anyway, let's go with it. In order to improve security, the document you find says, I've missed a bit. Fancy officer, blah, blah, blah. So you search the front desk for the code, and then you find a document that says bathroom codes will no longer be written down. Instead, please memorize and follow the procedure below to access the bathrooms. Well, okay. It's not going to work for me, but the document goes on to explain that each button to be pressed can be found by starting on the previous button and moving to adjacent buttons on the keypad. Okay, so we've got up, down, left, and right. Each line of instruction corresponds to one button, starting at the previous button, or for the first line, the number 5 button. Press whatever button you're on at the end of each line. If a move doesn't lead to a button, ignore it. You can't hold it much longer. We're desperate. Let me in. I need a wee. So keypad, yes, this is how I see a keypad. We're starting at 5. And you start at 5 and you move up to 2 because our puzzle input is U, so up for 2. And you move left to 1. And you move left again, but you can't because you'd be out of bounds. So do we just drop the L? We ignore it, it said, didn't it? It said yeah. If a move doesn't lead to a button, ignore it. So this is about when we hit the bounds of the keypad or the box. We need to stop and move on to the next line. So starting from the previous button 1, you move right twice to 3. Okay, so RR takes us from 1 to 2 to 3. I think I'm getting the hang of this. And then you end up with, so 1 is where we end up on after the first line. 9 presumably where we end up after the second line. Yeah, okay, so 1985. So let's, for now, return 1985. Whoops. We will tell the compiler that we're not using input at the moment. We'll put the underscore in front of it, which says, yes, we know we're not using that variable at the moment, and that's deliberate. And we will sort the tests out. We will say code, and we will change that to 1985, and we will grab the puzzle input, which is here. Copy it. No, we're not copying the puzzle input there. We are putting the puzzle input in a file. called input.txt. Let's do that while we got it in the clipboard. And then we'll go back. What we actually want is the sample input there. And we'll put that in Okay, and then we can get rid of these tests. All looking okay. So if I run the tests now for day 2, part 1, and this is test, that passes. So happy with that. All right. So we're ready to go. We've got our puzzle input, our test passes, and I think we are, yeah, I think we're good. So what I'm thinking then with this is that I need something, I need a keypad. I need to obviously be able to move around it, but know when I've hit the boundary, or move until I can't move anymore. It's not necessarily about hitting an edge, is it? Because you might hit an edge and then move backwards or something. If you hit the right edge, you might move backwards, or so it's about getting to a point where it's impossible to move further, and then taking that number, and then that is my code, and finally then I can have a wee. So I think what I'm going to do then is I think I'm going to use HashMap. So standard library, HashMap. So HashMap, and I think you can do you can take an array. Yeah, here. You have an array, create a hash map from it. So that's what I'm going to do to begin with. I think we will have keypad. So let keypad equals hash map. And that is going to be from an array, not that. And then what I'm thinking is if I have X and Y, so if I have this as 0, 0, and then I map out the rest of the keypad, then I can check where I am as I move around. And if a move is impossible, I can take the number. And if I can keep moving, I keep moving. So yeah, so I think for like 5, so what I'm thinking is if I have as the key, I have a tuple of 0, 0, and then I have that, the actual value in the map. So yeah, I think that will work. So if I copy that, and we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. And then all I have to do, and if you've watched my previous videos, you'll know I'm absolutely rubbish at X and Y, north and south, left and right. I've just got to get the coordinates right. So yeah, we'll see how that goes. 2, 3, 4, 5, 6, 7, 8, and 9. Right, so 5 is easy. 0, 0. 1 is going to be, so 1 is on the Y axis, we're up 1, but on the X axis, we're minus 1. Whoops. So I think, in fact, Y is going to be 1 for 2 and 3. And on the X, hang on. Let me think. Getting desperate for the loo here. I need to think quickly. So on the Y, we're at 1. For 2 and 3, we're going to be on 1. So it's the x-axis that is changing. So for 2, it's going to be 0, and for 3, it's going to be 1. Now 4, y is 0, and x is -1. 5 is easy. 6 is going to be 1 on the x-axis, and then here we are on the y. On the y, we are -1. Can I do this in one hit? Nope, not like that. So -1, -1, -1, -1, and then we have on the x, we have yeah, no, it's going to be -1, and then 0, and then 1 again. If that's right, this is going to be incredible. Okay, so HashMap from. So there's my HashMap. Now I need to know where I'm going to be. So let's go. Mute position is going to be a tuple of 0, 0 to begin with. So let's do that. And then I think we're going to need the same. We're going to need to know where I am. And then I'm going to need to know whether the next position is feasible or not. Okay, something like that. All right, and then we can say let code equals input, the lines of the input, which gives us an iterator, which we're going to map over each line. So we then get line, and in the inside of there, we are going to, what are we going to do? We are going to take the chars of the line, so each individual character in turn as an iterator, and then we'll fold over them. And we'll take the initial input, then the closure, which will be an accumulator, and the up, down. I'm going to call it the up, down, left, right. And then we will match on the up, down, left, right. And we will say if it is, if our instruction, if our letter is up, then we will assign the position. So our position will be, so for going up, position X is going to be fine, but we're going to need to increment position Y. So we do that with add 1. And then we're going to need another 3 of them, and then let's do a default of panic just in case. So up, down, let's go left and right. So if we're going up, this is fine. If we're going down, we'll sub here. And we'll go over here. So if we're going right, we're doing add 1. And here we're doing sub 1. Alrighty. So that's the end of the map. That's the end of the fold. I want that. And then here, I think. Is this right? Where's my, that's the end of my fold. It's the end of my map. And we're going to need to collect there, aren't we? Okay. And then here we will say, if keypad dot contains key next, then position equals next, because we found yeah, so we're finding where our next, so here we are finding, whoa, in our match we are identifying where we intend to move to, and then if that is within our keypad, it's within our coordinates, then we are going to move to it, and we want to take the get the value of that, I think. Else we will return the accumulator. Formatter failed. See confirm info. Conform info for information. Collect expected expression. Collect expected expression. So something a bit squiffy somewhere. So we've got, here's where my map starts. That's my map. Do I need one of those in there, maybe? Oh, that's happier, I think. So let's just print. Let's see what we've got. So print ln, and we want format. So stick some of that in, and we'll put code in, and we'll need to return something that's wrong for the, if you're running the test and the test passes, it suppresses any print within the code that's executed. This looks all happy, so I'm hopeful. So we're running day 2, part 1. Code, argument never used. Something's not happy. Oh, there we go. That might be the reason for that. I did, yeah, let code. Compiling HashMap. Okay, so we need to use std collection HashMap, and let's try that. Do not find collection in collections. Is it collections? Maybe. Code. Inputs. Huh. You've got to take away when you start using a variable, you've got to take away the unused prefix. Call method add. Okay, so I need to I need down here to say that this is a I32, I think. And I'll do the same for next. I32. I'm going to try and run the test again. Yeah, we need to import std ops, and then we can use the curly braces to import add and sub at the same time. Maybe this time. Expected position next. What was that? Expected due to this type. Position equals, yeah, I don't need to borrow there. So down, yeah, okay. Forward, get rid of that. Is this because I need to do something like the compiler figure it out? Expected integer found option at integer. Keypad. Oh, do I need to? Yes, I think I need to hash map here and say that it is an I32, I32. Does that sort things out? No. Sort things out, it does not. Oh, so this will need to be our first position, which is going to be 5-5, isn't it? So we can fix, no, 0-0 is right. This needs to be keypad get position. Conform info. Unclosed delimiter. Ah. Oh, I've got an extra. That's not going to help. Oh, I get 56983. Oh, that's because we are running the puzzle input. Let's try it with the testing. Yeah, let's try running the test instead. Okay, yep. So here we get the expected 1985 back. So now I just need to iterate over that, unwrap each number and return it as an I32. So let's try and do that. Down here, we can get rid of this. And then I will say code.into iter, turn it into an iterator. And then we will fold over that. And we will create a string. And then we have our closure, which is accumulator, and then we'll say we have our code. And then the accumulator we will add to the accumulator on each iteration the we've got some, so this is going to be our, let's call that key, because that's each keypad number we're going to press. So we're going to add key dot unwrap, and I think we're going to need to borrow here, and then we want to string that, turn it into a string, and then we're going to pass all of that to an I32. And we're going to need to call unwrap on that. Unwrap's been in the news this week. So yeah, let's see. So let's run the test again. The test passes. Right. Okay, moment of truth. Let's run it with the puzzle input. Here we go. We get 56983. There we put it in, and I just are we going to get a gold star? If I don't get a gold star, I'm just stopping the video and I'll deal with it on another day. Fingers crossed. Here we go. 3, 2, 1. That's the right answer. Thank God I can go for a wee. Bye.